In this video, we're going to discuss the cylinder and how to find its volume. First of all, recall from your middle school geometry years that a cylinder is made up of two congruent parallel faces that are circles. So very similar to the prism with respect that it has those two congruent and parallel faces. But unlike the prism where the bases are polygons, the bases in a cylinder are circles. And they're connected by a flat curved surface that's rectangular when it's flattened. So connected by this piece around the outside that when we flatten it out is in the shape of a rectangle. To find the volume of a cylinder, we're going to multiply the area of the base, represented by capital B, times the height or the altitude of the cylinder. Now the area of a base, to find the area of a circle, that's really just pi times r squared. So if you look on your formula sheet to find the volume of a cylinder, it's actually going to say volume equals the area of the base, pi r squared, times the height, or the distance between the circles on the cylinder. All right, but in essence, notice that really it's area of the base times the height, which is the same formula that we use in order to find a volume of a prism. All right, let's go ahead and get into these examples here. In number one, it's talking about the Wild Chipmunk Paint Company, and it sells paint in cans of two different sizes. The small can is called the touch-up can and has a diameter and a height that are each 6 inches. The larger container, called the Paint the World can, has a larger diameter of 16 inches and a height of 20 inches. They tell us that in every gallon there are 231 cubic inches, and they want to know how many more gallons does the larger can hold than the smaller one. And I'm going to say they don't tell us what to round to here, so we're going to round our answer to the nearest tenth. All right, I'm going to go ahead and begin by drawing these two cylinders so that I can kind of get a visual representation of what we're trying to work with here. So here's my smaller can. The diameter of the smaller can is 6 inches, which means the radius is 3, height 6 inches. And then the larger can, which I'm going to put over here, has a diameter of 16 inches, meaning that its radius is 8, and a height of 20. So what I'm going to do is go ahead and find the volume of both cans. So volume, using my formula from my formula sheet, volume of the little can is going to be pi times r squared times h, or pi times 3 squared times 6. And now I'm just going to multiply in my calculator 3 squared times 6. So exact volume is going to be 54 pi cubic inches. For the larger cylindrical can, again, the formula is volume equals pi times r squared times h. But in this case, my radius is 8. The height is 20. And again, I'm going to grab my calculator and I'm going to multiply 8 squared times 20. And I find that the volume of the larger can is 1,1280 times pi cubic inches. So at this point in the problem, I've got a couple options. I can either now go through and figure out how many gallons are in each can. That would be one possible way to finish this problem up. And then once you know how many gallons are in each can, subtract. I'm going to find the difference in volume, or in other words, how many more cubic inches the larger can will hold than the smaller can. So the difference is going to be equal to the 1280 pi, the amount of cubic inches in the larger can, subtract the 54 pi, or the amount of cubic inches in the smaller can. And when I get my calculator out and do that, I find that the larger can contains 1,226 pi cubic inches more than the smaller can. I know that there are 231 cubic inches in every gallon. So I'm going to take the 1226 pi, divide that by 231, and that'll tell me the difference in gallons. So to the nearest tenth, 16.7 gallons. By doing it the way I did it, I only needed to convert to gallons once instead of twice. But if you had done it that first way and found the number of gallons in the small can and the number of gallons in the large can and then subtracted, you would have ended up with exactly the same answer. Okay, let's take a few minutes and discuss Cavallari's principle. This just says that when two figures have exactly the same height and the same cross-sectional area at every level, then their volumes will also be the same, which makes sense. You find volume by doing area of the base times the height, and if the area of the bases are the same and the height are the same, they're going to have the same volume. Since the figures that are given in the picture all have a cross-sectional area that's 6 square centimeters, we know that their cross-sectional areas are the same. We're also told that their height is the same. Cavallari's principle tells us then that their volumes must be the same. All right, so in looking at this question down at the bottom of page 8, it says 2 stacks of 23/4 are shown. One stack is stacked neatly and forms a cylinder, where the other stack is not quite so tidy. They want us to use Cavallari's principle to explain why the volumes of these 2 stacks are the same. Well, these guys are going to have the same exact volume because they both have the same number of quarters, meaning that they're going to have equal heights. And the same area for each quarter. And Cavallari's principle tells us if we have 2 figures with equal height and equal area at each level, they must have equal volumes. All right, so as always, I want you to take a few minutes, think about what you just saw. Think about what you think might be important that you're going to have to understand and be able to take away with you from this video. Summarize your key ideas and important understandings up at the top of page 9, and then see if you can apply what you've learned in the course of the video in order to solve the questions on page 9.